Screencast 20.2, oxidation number. We define that as being the charge that an atom would have in a molecule or an ionic compound if the electrons were completely transferred. It's most often used for organic substances where you want to keep track of the charges on individual elements, even though you realize that they are not formally ionic. And there's several rules to help you do this sort of bookkeeping. If you have a pure element that's alone, now it could be diatomic, but there's no other element present, that has an oxidation number of 0. So for example, if you just see sodium separate, not part of sodium chloride, but just separate, or if you see oxygen separate, like H2 plus O2 making H2O, both the H2 and the O2 would have an oxidation number of 0. Let's take a look at these substances here and figure out which ones have an oxidation number of 0. No, no, yes, yes, no, no, yes, no, no, yes, no. So it should be neon, chlorine, hydrogen, and nitrogen. Now for ions, it's just what you would think it would be. If it's an ion like lithium chloride, the lithium is +1. Iron's +3 when it's +3, and oxygen is -2. In other words, the oxidation number is equal to the charge for ions. Oxygen has a couple of weird exceptions for oxides. Normally, oxides are -2, but if you have hydrogen peroxide, or a dioxide dianion, both of which are relatively uncommon, in those cases the oxidation number is -1. Hydrogen also has a slightly unusual case because it can be +1 or -1 in the case of a hydride. So if you see it in the beginning, it's usually +1. If you see it at the end, like lithium hydride, it would be -1. See, when it's bonded to a metal in a binary compound, such as lithium hydride, it's -1. All other cases, it'll be +1. Now for the group 1 and the group 2 ions, they're always +1. Group 2 are always +2, making life simple. And fluorine is the only halogen that we can give it a charge always of -1. The other ones can vary. The total oxidation numbers in a molecular ion is equal to the charge. And if it's 0, the total sum of the oxidation numbers will equal 0. So these are the rules for oxidation numbers screencast.